Welcome everybody to CSE Review Session Season 5. I don't know why I decided that it was going to be seasons, but uh, this is the fifth semester in a row I've been doing this. That's kind of scary. Um, that's really scary.
Halloween's coming up. I guess scary is a good thing.
Yeah. So we'll start with, I guess, introductions of who we are and why we're qualified to be here. I'm Logan. I'm the head TA for the course. That's all the qualifications I need.
Okay.
I'm Joe. I've been TAing for 5 semesters now, so.
This is
Well, yeah. I hope they can hear you, Joe. So
they can. I boosted a little bit.
all right. What's up, guys? I'm Leo. Yeah, I've been TAing for 2 semesters. No, this is my second semester TAing 116. I have not made 2 semesters yet. This is my second semester. So I'm not that far from all of you. I just want to make that clear. So
All right, so we are going to be here every Wednesday from 3 to 5-ish p.m. Hopefully you saw the Piazza post that says that the 5 is a very strong on the ish. If you guys stop asking questions at 4:15 and no one's here anymore, then we're just going to kind of get going. That's kind of how we do this. So I guess the first thing we'll do is we'll open up to questions. I think is the best way to start, and then we can dive into topics as people have questions revolving around them. So if you could start putting questions in the chat, and then we'll start getting to answering some of them.
yay, questions. We like questions. Questions are the best part of this, honestly.
I think liking questions is a slightly debatable thing, but we take those.
I like questions. Questions are meant to be answered.
Questions are meant to be answered. Yes, that is correct. Oh my, okay, 2 questions quickly. Okay, is there CSE 116 specific tutoring? No, not that I'm aware of, right? The only official tutoring source that the CSE 116 class has, and it's not a tutoring source, is going to office hours and coming to this review session. Anything else is not condoned by the class and can possibly be academic integrity violations depending on what it is. That sound about right? Darcy? Yeah, too?
Yep.
Okay.
If you want to get tutoring, you can also talk to Jesse and bring your tutor to Jesse so he can go over what you can and cannot go over. So that's another thing. But that's that seems like a lot of work to go.
That's a lot of
get
work.
A tutor when you can just go to office hours.
Yeah, we're really helpful at office hours, and we try and go over concepts here. So, like, the hope is that we can be helpful here as well. I don't know why I opened that folder.
Think of this as your own personalized tutoring session, where
we're
ask
here.
as many questions.
Yeah, we're here to answer questions that you guys ask of us. So, here we go. Here we go. No, not there.
Hold on. Here we go. Here we go.
We're looking. I'm looking for slides.
I know exactly what you're.
One moment, please. Oh.
Oh.
Ooh.
I like the
this one.
The third one.
Wait,
like
no way. This is so close to the right date too. See the original name of the file? This is so close to actually being correct.
But there's something that you have to change there. There's one other thing that we go over in there. Oh, well, you got to put.
Well, we're not doing this part.
Yeah, and the.
I'm just gonna stop at this point.
Yeah. Okay, that works with me.
I'm just gonna. I guess I won't even go to the slide. I'll just kind of stay here. All right, we're working on going over stack and heap. You'll stack. Sorry, not heap.
Not heap.
Well, we're working on going over stack. You'll notice that we're a very organized bunch of people. When it comes to these, and these are very, very informal. So a lot of times it'll be a couple minutes for us to figure out pulling up slides and that kind of stuff on exactly what we want to talk about and how we want to talk about it. So I'm gonna pull that up, and is it this? I think it's this. Yeah.
Yeah, this should be this.
Yeah,
that's it.
This is okay. Yeah, this is what I want. Okay. Okay.
Okay.
There we go. I fixed everything. Okay. So we do that. Then we do that. We're back. It's been like many weeks since we've done this.
A long time.
And by weeks, I mean months. Okay. So these are slides from a couple semesters ago that I just very, very quickly updated. So we're going to talk about some stuff in here, and then we're going to go talk about Jesse's slides, and we'll kind of re-explain it and go super slow as we go through. So stack is confusing. We understand that. It's one of the more like, I don't want to say harder because it's not like an extremely hard topic. It's tough to get your head around, right? It's just kind of difficult. So do that. Okay. So what is memory? Memory is the RAM that's in your computer, right? And when you run a program, it uses different pieces of memory in order to store variables in the stack. In order to store data somewhere, right? So every time you make a variable, it gets stored somewhere, regardless of what variable it is. Doesn't matter. It's going to get stored somewhere. It's got to be accessible to the computer at any given point, right? If you make a variable X, right, you need to be able to access it 3 lines later. It can't just be instantaneous and that's it. So that's what RAM helps us do. So RAM is the memory in your computer, right? Wow, this is a really short presentation. I really didn't think it was that. I didn't think it was that little.
It's 2 slides. All right, let's move into a stack example, guys.
Okay, so these are Jesse's slides, and what we'll do during these is we will start by going through some slides that either I put together in a previous semester or that we've put together more recently, and then we'll start talking about Jesse's slides and going through them a little bit simpler. So I'm going to skip over interpolation versus compilation. The TLDR of this part that you realistically need to know is that some languages are interpreted, that they're read and executed one statement at a time. Other languages are read completely and then executed completely. That's really all you need to know. The important part that you get from this is that Scala is a compiled language, meaning it reads the entire thing, then it runs the entire thing. So if you are coding and you have a problem, you have an error that pops up in one of your objects somewhere, right? Even though it has nothing to do with the other objects, it's still going to compile because it compiles the entire project and then it runs the entire project. So if you have an error somewhere else, you know something doesn't work, comment it out or fix it. So that way at least it doesn't error. So that way you can run something to test it. Pro tip. Yeah. Oh, the scariest image known to humankind. The Java installed on billions of devices. I'm trying to. What do we have to actually talk about here? Yeah, we talked about that. Okay, so the RAM looks vaguely like this. Now, obviously, it doesn't look exactly like this, but a section of RAM would look like this. So it's each one of these is a space of memory, right? So this space of memory is used by another program, and all of these are going to be used by our program, and then this space will be used by a different program. So our goal here is that we want to talk about how stuff gets stored on our RAM as we go through our programs, because it is really important, because we won't talk about a huge amount now, but we will talk a huge amount about it in other classes later down the line. So the memory stack works like the data structure stacks, which you'll learn about later in the semester. Important part of this is it's last in, first out. So the last thing that's in is the first thing that's out. So it's like a stack of plates. If you have a stack of plates or a stack of cards, to get to the third card in, you have to take the 2 cards on top off. To get to the third plate, you have to take the third plate off, right? The first 2 plates off. So the last thing in is the first thing out. So the thing on the top is the first thing that gets taken off. And please ask questions as we go along, because I'm going to just speak to absolutely the void of nothingness, and I hope you get it.
If plates confuse you, ask questions. If plates very much confuse you.
Okay, I'm going to ignore that question. We all know who that is, so we're ignoring that. Yes. Okay, so every time we call a method, we make a new stack frame. So a stack frame is something like we had up here, right? Where we have our program memory, right? So it's a piece that takes up space in the RAM. And you can only access values that are in the current stack frame you're in. So you can't access something in another stack frame. Can we explain the plate analogy in another analogy? Yes. Hold up.
I'm looking at plates. Hello, plates.
Plates. Okay. Hold one. Okay. We will refer to people by their Twitch usernames just so everyone knows. So not a regular day. Give me a minute. And Swimi. We will talk about that in a moment. That will be part of this next part.
And
so
this is the phonetic meaning of your name.
Yes, that way we don't say it wrong. Okay. So this is a stack of plates, right? I think this is pretty obviously a stack of plates. We can all agree on this. So in this stack of plates, right? If I want to get to the third plate, if I want to get this plate, the only way for me to get to this plate is by taking the 2 plates that are on top of it off and then taking this one. Here we go. Hold up. We're pulling out the Microsoft Paint early in the semester. Okay, right? So we've got the stack of lines, right? Whatever it is, right? The only way for us to get to this one here, right, is to remove everything here, and then we can take this one off. Because we can't take it off without taking the plates that are on top off. So when we say last in, first out, that means if I do 1, 2, 3, 4, right? And these are 4 things on the stack, and then I add this one, the order in which we look at things on here, the order in which we execute things, is going to be 1, 2, 3, 4, 5. And then let's say we add another thing here. Now the order goes to 1, 2, 3, 4, 5, 6. Does that make sense on a regular day?
That do be how the stack works.
Okay.
Perfect.
Assuming the stack of plates represents the stack frame. Yes. The only problem with how I just explained this is imagine it's flipped. The stack goes downwards. So in any of these examples that you'll see that we'll talk about, we go downwards. So the thing on the bottom gets executed first. It's just kind of how it gets represented. It's the same kind of thing. It's whatever's the last thing that's on there gets executed first. Okay, so let's talk about let's go to Soimi's problem, which is going over the how to differentiate which variables to use when multiple variables with the same name appear in a code block. Joe, would you like to take this?
Sure. So this is basically just going to be scoping. So I don't have IntelliJ set up on here right now, but we'll use Notepad. Or actually, if you want to pull it up,
yeah, you want to pull
sharing your screen. If we could just write a little code example here.
All right.
So,
yay code.
Yeah. So basically, what's going to happen is every time you're executing a new segment of your code, so whether that's going into a function, going into a for loop, or going into a function, or going into a class or an object, which we'll explain a little bit more further, it's going to open up a new stack frame. So within that stack frame, it doesn't see the variables from outside, right? So if we have, for example, function, I don't know, my function, right?
Also, just be prepared that basically everything we write in this class will be pseudocode.
Yeah.
Because we're lazy. But you should still understand. Do you want it to take any parameters?
We don't need to.
You don't need to.
Yeah. So
let me rephrase this. The pseudocode will look a lot like Python.
Yes.
But just know it is pseudocode, and if you took this and put this into IntelliJ, it won't run.
Yeah. So then say we have a variable x in here, right? And we set that equal to like, I don't know, 5, right? So then this x can be used anywhere below this function, right? But then if outside of this, I also have a different x in a different function, right? So if we had like my function 2, Dose.
Logan, switching up the language on us.
These two X's being completely independent stack frames. So they're going to be completely independent from each other. They can be seen as their own variable. So on the stack, they would just be completely separate in different segments of program memory, basically.
Yeah, so if we were to print my function and then we were to print my function dose, we'd get two totally different results, because while they're both named X, they're not in the same stack frame. So part of what we said in here, right, was that anytime we call method, we make it into a new stack frame. Anytime we call a method, anytime we go through an iteration of a loop, it's a new stack frame. What else is a new stack frame? There's others.
Loops, functions, classes, objects.
Yeah, anytime you go into a new class, a new option, object, that kind of stuff.
What else? There's more, but I'm blanking.
There's definitely more, and we'll get to them as the semester goes on. But you don't need to worry about it right now. Just the function, new function calls, and the new method calls and loop. Every time we loop through something, those are the big ones, right? Okay. So stack values in the current stack frame, only stack values in the current stack frame can be accessed, and that's what Joe was showing here. Yep. Aren't loops code blocks? They are. What's the technical term that we say?
I'm pretty sure Jesse uses code blocks.
Yeah, code blocks, but every time you go through a loop, it does the thing. I don't know if I explained that. That definitely wasn't a good explanation. Every time if I have a loop, right, and it says for x in range of 0 to 10, right? Let me get this even somewhat correct in Pseudocode. And I say y equals 10, and then I say x plus y, x plus 2, right? And then after the loop, I wanted to print x, and I wanted to print y. Actually, let's say I did y equals. Let's say I did y equals 4 outside of the loop, right? And then in the loop, I said y is equal to 10, and I did x plus y. Pretend x equals 0 here, okay? So in this pretending, right, we start with y equals 4, and then we say x is equal to 0. Then inside, oh wait, let's do that. Okay, I like this better. Inside this loop, as we increment from 0 to 10, we're going to add x to y. We're going to add y to x. Again, very terrible syntax that we write here. But in the loop, we've actually defined that y is equal to 10. So every time we go through the loop, we're going to say x is equal to x plus 10 as we go through the loop. And then after the for loop, we go back to y not being 10, because it only knows that it's 10 inside this for loop. If I was to make the variable, if I was to make z inside here and set it equal to 12 or something like that, and I tried to print z here, it wouldn't actually be able to find z, because it was only accessible inside of the loop. That's the concept of scope. That's the concept of variable scoping. And then, so methods are like folders to put functions in. No, we're just going to interchange. Methods and functions are different, but we're going to interchangeably use the words methods and functions for this class.
You will understand what functions are later on in the course, but we're going to call them. We're going to, because we've used other languages, we're probably going to call methods functions, and we're going to call functions methods. Just know that we're just defining.
Anytime I say def, that means it's a function or a method.
Yes.
Don't worry about the exact nomenclature I'm using. Anytime we write def, it is something you can call that you'll get an answer. How would you change the global variable inside the for loop? You're going to have to be a little bit more specific there.
Dreamseeker, are you talking about changing the y equals 4 to y equals 10?
Okay. So yes, he is.
Okay, yeah, so just like it's written here. So reassigning a variable that's outside of the scope, but like above it in scope, you can just reassign that right there. The major point here was that var z is not visible outside of the for loop.
That's like the big deal. Actually, that's the really big deal. The whole thing is that you can't see z outside because it's not in scope. The other thing here is that once we go into the for loop, right, that y gets reassigned to equal 10 every time.
Yep.
All right, we move on. We soldier on. Yeah, code blocks control variable scope. So we're waiting. So yes, a loop is in a code block, but here, similar to stack frames, but values outside of the code block can be accessed. So a loop will start a new code block, right? Which is why we can access y and x inside the loop. But this variable z will only be able to be accessed inside this code block. I'm waiting a moment for Andrew Olenson. Misses. How will x and y print? I mean, they'll just print us whatever numbers we threw. So I guess y will print to 10.
Y would be 10, x would be 100, I believe.
Yeah, x will be 100, y will be 10. And then z won't print. You'll actually get an error thrown when z goes to print that says this variable doesn't exist. All right, we move on. Okay, we just talked about that. This is the important bit about this whole thing, right? Variables and values in the same code block cannot have the same name. It won't work. Literally, if I open IntelliJ right now, which I'm not for a couple of reasons, if you open IntelliJ right now and you start typing var x and then right after do var x again, it will throw an error that says there's already a var x. But if you have another code block after the for loop and you look for z, we can't find z in the code database.
No.
So if you wanted to access the same z between two different code blocks, you would need to define it at the function level. Outside of both those code blocks, but like above them hierarchically.
Yeah, so you put it like here. Yeah, you'd put it like in here, like c is equal to 12 or whatever. That way you'd be able to access it outside. But anything that you declare inside of a code block can only be accessed. It can't be accessed by like upper code blocks. That definitely didn't make sense.
And for further explanation, if Logan, if you can make another loop after this real quick.
Yep.
So say right above this loop you defined z. So like var z equals whatever, right? So this z has no relation to the previous z. You can assign it to the same values, but it's a completely independent variable. It was never influenced by that previous for loop.
So yeah, so if we were to print this z here, it would print 22.
Yep.
But this z won't print. All right.
I hope that makes sense.
Yeah, please tell us if it doesn't. We'll you more than happy to come back. We're gonna push through this for a little bit. Yeah, it has to be before the for loop if you want to access it outside of the for loop again. Anything that you declare inside of the for loop will only be able to be accessed inside of the for loop.
Yep.
Okay. When the end of a code block is reached, i.e. in this case a for loop, all variables and values created within that block are destroyed. That's the big explanation there for loops and stuff. Is that when we reach the end of a code block, we reach the end of our for loop, everything that was made within it is destroyed. It was removed from the stack. So this is a very not correct example of language, but is good enough for what we need to do. So this is a memory stack example on how we use memory and how we kind of show what the stack looks like at any given time. So there's a function, you call the function, the first thing that's in the function is these command line arguments or whatever parameters you have inside, right? So that's the first thing that gets put on the stack. After that, we're going to go through the function line by line. So I equals 5. Well, now in the stack, we have something that is named I and has a value of 5. After that, we're going to begin a new stack frame, right? We're calling a function. We're calling compute factorial, taking I in with it. So we're going to begin a new stack frame. Again, every time we call a function or a new object, we create a new stack frame. So we'll create the stack frame for compute factorial, and then we're going to go up here. So the first line in compute factorial is going to be our parameter. It's going to be n and what the value of n is. N is whatever the value of I is because we passed it through. So it's going to show here that n, we have a variable named n, and its value is 5 because that's what got passed through. Next, we have a result and a value with the result. And then we're going to go into a loop block or a code block. You can denote these however you want, but please do denote that you're going into some sort of block here. We're gonna declare I as 1, and we're gonna continuously change the value of I as we go through, as we do whatever's in the block as we increment. So as long as I is less than n, so I is less than or equal to 5, we're gonna do whatever's in here. So the next line we have is result. So result is result times I. So if you watch, we'll start to change the value of result here as we go through. So we go back up here, we change the value, we change the value result. Is a loop block the same thing as another stack frame? No. A loop block and a code block are the same thing. The big thing with loop blocks and code blocks is you can access things that are above them in the stack. With a new stack frame, you can't access anything outside of that stack frame. That's like the big difference there. So as we go through this, and I'm going to go through this a little bit quickly, you'll see that we multiply through. Oh, Jesse just literally skips it. So we iterate through, right? And this result value, the value that has the name result attached to it, changes value as we go through. So eventually, I becomes the value of 5, and result has the value of 120. We then return result. So we reach the end of the code block. So we're going to delete all the stack storage that was used in this block. The variable I doesn't exist anymore because we got to the end of the stack, this code block, the stack frame, and we're going to return the value that is being held in result. So then we have function returned 120, and then we're going to assign that to our variable name that we have here. Value 120. Printing doesn't do anything on the stack, and then we're left with this on the stack, and then the stack frame goes away. Okay, Leo, would you like to answer the questions?
Yes. It's only one question. Variable scoping is a term to describe how variables work inside code blocks. Yes and no. Variables, it's like a portion of it, yeah. Like, I would say variable scoping is more so to determine how variables get used throughout the entire program, not just code blocks.
Scoping as a term just determines when variables are accessible.
Yeah.
So for the code block example, yes, it would determine how they actually work within that context, where you can view variables that are outside of the code block but within the stack frame. But you can't view variables that were defined within the code block outside of that code block.
So then our stack closes, and that's it. That's the end of our stack. Important thing about the stack, only primitive data types are stored on the stack, so doubles and floats, ints, longs and shorts, chars, bytes, and booleans. That's it. Nothing else is on there. Notice the distinct lack of something that you might think is a primitive data type. Leo?
Is it a list? Nah, I'm kidding. It's a string.
Notice, so notice the lack of the fact that it says string on there, right? Strings are not a primitive data type. They don't get stored on the stack. You don't need to worry about where they get stored. We'll talk about it later in the semester. But just know that only primitive data types are stored on the stack memory. This is the important part here. Does anyone have? So everything else is stored in the heap. It says it here. I can say it, but that's the only thing I'm allowed to say about it. We'll talk about it.
We'll talk about heap next week.
Yeah. Is it next week?
I hope it's next week.
I don't know if we're talking about it.
Touched on Friday.
Is it?
Yeah, next week. It is next week. Okay.
Yep.
So, wait, that's this week. That was today. But that's LO2. We're not doing that today.
Yeah. So don't worry about getting to it.
Yeah. So, do we have more questions? Because we probably have answers.
Any more questions about stack memory and plates and lines and stuff? Oh, unit testing.
Unit testing is huge.
Okay. We can go unit testing. Another example.
Another stack example.
We just pull out.
I mean, we could just pull what
we could just do this one. Yeah.
Yeah, let's do this.
This is easy enough. Yeah. All right. So we're gonna go through here. So here's what we're gonna
do. And now we bring out the notepad.
Regular notepad. So on the right, I'm gonna write what the stack is as we go through stuff. So this will be our first piece, our first stack piece, right? Let's do it this way.
Yeah, I was just about to recommend that.
It's fine, because I was a step ahead of you.
You're always a half a step ahead of me.
Okay. So, what's our first thing that's going to be on the stack? Assume that this isn't a main method. I'm too lazy to write it. So, our first thing is we're going to have x is equal to a function call. So, we're going to talk about the function. So we'll begin a stack frame. Immediately within that stack frame, we call a function. So we're going to make a new stack frame, many lines down. So we're now in my function, right? My function has no command line arguments. In here now, our first thing is we're going to have name is x. Is there a way I can make this bigger?
For simplicity purposes, just change the second begin stack frame to begin my function frame.
Yeah.
Just for simplicity reasons.
Okay, so name's x, value is 5. Then we're going to go through this. So we're at this line now, x plus 1. Okay, well that's simple enough. We just add 1. X plus 2, add 2. X plus 3, add 3. Now, this should say that might make it a little bit easier. So at this point now we're going to return x. This is the end of our function. So we're going to return x to here, to our first stack frame. So we'll say name x, value, value 11, right? And now this stack frame here is going to close. For learning's sake, I'm not going to just delete this, but this doesn't exist anymore.
Yeah, you could put in parentheses destroyed, like above. Yeah. So that stack frame is now destroyed.
So now we move on to the next line. Y. Y is equal to my function dose. Oh, okay. Well, now we have to make a new stack frame here. So I'm going to make that here. I'm just copying this. So in here, we have no parameters. Okay. We have a variable named x though, so we'll go name x.
Great spelling.
With a value of 7. I don't want to hear it from you. We're then going to add 4 to it. We're then going to add 5 to it. And then we're going to add 6 to it. And then, at this point, we return x. So we're going to end the frame. And here we're going to go name y, because our return value, our value we're assigning it to here is y, has a value of 22. And this one's also destroyed. And then we're going to print x plus y. So what goes on the stack for printing x plus y? Nothing. Damn straight.
That is what we like to see and read.
The return statement destroys it. Yes, return statements do destroy it. So yes. We go end stack frame here. That's it. That's the whole stack frame for this. The whole 3 stack frames of running the 2 functions.
And then that main stack frame gets destroyed too.
Yeah.
And at the end, this will get destroyed.
Yeah, and now this is destroyed. Because this is the end of the program.
And now we finished our program.
So this up here was our main stack frame. We then, X was created via this now destroyed stack frame called myFunction, where we went through and we iterated. Y, the value for Y came through here, and we ended the stack frame, destroyed it, and then we ended the stack frame here. Why nothing?
Why? You mean for main?
I assume it's for print.
Yeah. I assume it's print, yeah.
Because nothing gets saved to the memory, it just goes right to standard out. Main stack frame gets destroyed before print statement. No, there's nothing that goes on the stack for print.
Yeah.
You're not saving any values there. You're just outputting something.
Print doesn't store or like return anything to store anything, so it just does what it does.
How would our quiz look like? It's going to look like a quiz. It's going to have questions. You will read them and then answer them thoroughly.
Logan's busting your chops. I would say
I made the quiz. I can't. I helped make the quizzes. I can't say what it is.
I would say go to the CSE 116 website. Look at LO1 for explain and read and explain.
Hold up, wait.
And that is what you will be expected to do. That is exactly what you will be expected to do.
And we see read, explain, write. You will be expected to here. For LO1, on the read, which is the quiz, you will be expected to trace through a program and track the state of stack memory through its execution. And for the interview, you will need to be able to describe the concepts of stack memory, stack frame, variable scoping, and unit testing while reflecting on their importance in the programs we write. What do you mean we aren't writing an entire stack?
What you are expected to do will be given to at lab.
We can't say anything more.
Yeah.
Why are there 3 stack frames with only 2 functions? Well, what about this?
We said imagine that there's a main there. You know what? Just you should just write it for simplicity purposes. There you go.
It'd be longer to write that than it would have to just write def main.
Yeah.
Do I care? No.
It's okay.
So we're good as long as we review lectures and slides, right? No trick questions? There are no trick questions.
There's no reason for us to give you trick questions.
We want you guys to succeed. We're just the reason that we do quizzes and interviews and stuff is to confirm that you guys understand the knowledge that we are giving you.
I think they also said, yeah. So Soimi, you also asked, is the interview hard? No. It will depend on how you feel about it.
If you understand the material, you will be fine.
Yes.
We're not going to be trying to get you with anything crazy.
At least this early in the semester. You have stage fright. Don't worry about it. You have plenty of time to be able to do it. It's going to be a one-on-one thing with your TA. It's not like you're going up to the front of the class and presenting. That would be terrifying. We would never make you do that.
I have stage fright too. It's okay.
We also purposely, because we understand that some people are shy and some people have we purposely have multiple times for you to be able to do this, right? Because we have makeups and then a third makeup with a head TA and then a makeup with Jess. There's the whole recovery plan thing in case you need to get over stage fright and stuff, this class does really help with that, and you're gonna have to do the interviews for jobs anyway, so it's a good thing.
So not a regular day. Difference between objects and classes. That is a next week thing, not a tomorrow thing.
We're gonna do LO1 because we still have labs going on this week for LO1. The way that we'll do these is more likely gonna be over like the last week of topics.
Can we go over unit testing from Andrew Wollenson? There we go. That's the question we need.
Can we go over unit testing? More examples. We can come back to more examples of stack and heap later.
If you want to give us examples to go through, sure. That'd be even better.
Go over unit testing. One moment. Let's see if I have slides.
We'll demo some unit testing, and then we can analyze the tests.
That's a good idea.
And show the stack for those.
I think I actually have slides though.
You do. You should. I remember them.
Yeah, no, I actually do.
But we use classes with unit testing, so I guess.
Not really. Oh, yeah, I guess I did. I feel like I have updated version of these. By the way, the reason we're here is we're waiting for IntelliJ to open. Just know that it does open as slow on your laptops as it opens on my desktop. AKA extremely.
Yeah, IntelliJ is not the greatest for loading in stuff. For loading in
8 gigs of RAM good for programming. You will be fine to start. I can't say that you'll be fine forever. You won't actually refer that. You won't be fine forever.
I think 220. You need more.
No, you can do it. You don't need that much.
In all honesty, you don't need that much RAM. It'll take you a bit longer to do some stuff, but like
realistically, you can have like a 2 gig VM and be fine.
Yeah, realistically, like if you're doing something that requires a ton of RAM, just use Google Colab.
Yeah.
I mean, you're giving them the cheap way out. You just gotta buy more RAM.
Leo and Joe.
Literally how Google Colab works.
You could also download more RAM.
Download more RAM.com. You can see why I didn't want to open IntelliJ. Because it opens whatever the last thing is, and this was the last thing I was working on.
Yes, well, you see that, but this always happens to you. So.
I know, this always happens. Every time. Without fail.
Always, yeah, for sure.
Why is that so low? It was only having me stream at 2,500 kilobytes per second. That's so low.
That really?
I just bumped it up to 5K.
Yeah, I would usually do 6. But
I don't think you can do over 5 unless you're like a partner channel or whatever.
No, I'm pretty sure you could still do 6. I mean, I could be wrong.
I don't know. I'm not worried about my internet here, so.
For the first time, yes.
For the first time in years, I'm not worried about my internet.
How many of you guys are... I'm very curious as to how many of our students live on campus and this is the first time they've had internet, which is very consistent so far.
Well, in dorms, it's consistent. It's not been consistent on campus.
Not consistent if it's the Wi-Fi.
Yeah, the Wi-Fi's been terrible.
But in dorms, it's consistent for sure.
My Ethernet's been booling. Do I still have? I think I have last semester's thing.
I don't see why you wouldn't. You know?
I don't see why either. Yeah, so just so it's known, I have a decently beefy desktop with like 32 gigs of RAM, and this takes forever to do. Yeah. So, we'd love to see it. Wow, I'm a genius. Do you see this? having a test package with literally
nothing in it. It's okay. At least we can go to first object now when you set up that Scala SDK.
Well, it's like freezing. It's doing things right now.
Yeah.
Intelligence.
You also have a lot of things open.
I really don't.
No, you do though. You do. You have like 7 different applications open.
Okay.
I'm sorry. 9. Sorry, 10 different applications.
But
open.
Leo.
Yes, but CPU usage though.
It's fine.
That's all IntelliJ.
That's literally all IntelliJ. Like, guarantee that's all IntelliJ right there.
Jeez.
It's actually not, but whatever.
It's all Discord.
It's all Discord.
It surprisingly is. Oh my god. I forgot.
Okay, we really went in. We really
did this function. Jesus Christ. I think this was just like whatever we wanted it to be. Oh my. Sorry for this
yeah, while Logan fixes this, does anybody else have any other questions? Just before we get into code examples.
Okay. I know exactly what I'm doing.
You should name it second object.
No, I'm deciding whether I want to make a class or an object.
It's probably probably easier to test an object.
Joe will know this, Leo won't.
I know this. I think I know
Leo had this too.
Yeah, I know this. Get out of here.
We don't use this in anything anymore.
Yeah, I know this. Get out of here.
Okay, you do? I don't remember when we took it away.
Get out of here.
Okay. Actually, I can start sharing screen now again. All right. We're currently making a function quickly. Let me screw with this for a moment. Was it presentation? Oh, goodness.
Yeah, that's it.
Yep, there we go.
Yeah, but I need to get to the other stuff.
I guess presentation mode is not the one to choose.
I think it's just escape.
It's not. There we go. Really? Really?
This is why we like IntelliJ.
Appearance. Exit presentation. Thank you. No, I can just go to here and then to here. And wait.
These are the technical difficulties we always face.
Font. All right, good enough. It'll be big. Maybe. Hopefully.
Can everyone see?
Yeah, if you can see it, please tell me you can see it.
Like, can you understand and make out the words and stuff like that? I'm hoping you can. Okay, so we got a yes.
We got a yes. Just trying to see if I can make it bigger. That literally did not change the size. This is terrible. She's literally not changing the size at all. I hate everything. Okay, whatever. This is good enough. Okay, so we have a pricing function here. Our main is going to call this a couple of times. So our weight, which we're bringing in. So we want to do something different depending on how much this weighs, right? So we're going to have an if statement here. So if weight is less than, was it less than 30?
30.
Yeah,
I think it's less than or equal to 30.
Whatever number we want to do works.
We want to return 5.0. Okay. Else if weight is less than or equal to 50.
Else if.
Yeah, I know how to do coding.
Yeah, we know code.
It's been a little while. We're going to be very rusty at actually running Scala for a little bit because many of us have not done it yet.
I'm not. No, I'm kidding. I might be. I won't lie.
Okay.
What are you doing?
Don't worry about it.
There you go. I'm pretty sure it's 2.5. No.
It doesn't matter.
Doesn't
The
matter.
exact numbers doesn't matter. I just want to make sure that's there. And then else. Let me take this out. Okay. So we have a function here. And this is an old function that many of us are familiar with. You might not be familiar with it, but the three of us are. So this is a function called pricing, right? Basically what it does is it takes the weight of a package and it's going to return the price of how much it costs to ship that package depending on what the weight of the package is. So if the weight is less than or equal to 30, let's say in this case it's 30 pounds, it doesn't really matter what the unit is. But if the weight is less than or equal to 30 pounds, it's going to cost us $5. Otherwise, if it's less than or equal to 50 pounds, so anything between 30 and 50 at this point, the price is going to be $5 plus however much more it weighs than 30 times 0.5. So an extra 50 cents per extra pound, basically. Otherwise, it's going to be, so if it's greater than 50 pounds, it's going to be $5 plus whatever the weight is times 0.5. So basically, as your package gets heavier, it gets more expensive to send. Makes rough sense. So we're talking about testing here, so we can do testing in a couple different ways. The first way we can do testing is the stupid way, which is go here and just go print line pricing 2, right? And then we can copy that and we just go here and we do it like 3 more times and we say like 38 and then we go here and we say like 55 and then we just we run it.
We say the stupid way, by the way, but this isn't necessarily a stupid way.
I don't know why this is not running.
This is a good way to check for quick things, but it shouldn't substitute proper unit testing.
Why is this not going?
Check your project structure. Sure, set up.
No, that's right. That's right.
That stuff is right.
I don't know anything else.
Do you have your do you have the entire project marked as source root as well?
Yeah.
No, it should be. Yeah.
No, I mean above it.
No, that's the right thing. Well, it's compiling something. Let's let it just go there and then figure out what happens after. Oh, lovely. I know what that is. Oh.
No, I mean you had it right.
No, it doesn't need to be
no.
I love it when just stuff decides to not work correctly. Why wouldn't it just work correct? That would be super convenient.
None of them have it.
Well, yeah.
Interesting.
I don't know why. That's super weird. Maybe because this file's like.
Maybe.
I'm just gonna do that and just do that and do that and do that and do that.
Fly and okay.
There we go. Worked. I quit. I don't know why things like that work. Okay. So we can run this, right? And we can go. Cool. Awesome. It worked. Great. We go, cool, great. These are answers. Yeah, these look about right. Cool. Awesome. But what if we like actually wanted to test these and make sure they ran correctly? So we do what's called running a test suite. So I do a POM. Lovely.
Okay, why was the POM so big?
I think because I screwed with the font size a lot, and then it did things. So we're gonna download source and documentation on our POM. That should be downloaded already, but I'll do it again. If you don't know where the POM.xml is, you go to the website here. You go to the GitHub. You go to pom.xml, and you get this file. Make sure it's in your code. So we're gonna make some tests. So we're gonna make a new Scala class. It's gonna be called Cool Tests for package pricing. Oh my god, that's huge. Why is that huge? I hate everything.
Time to go back to the settings. Change it to like 20 something.
40.
20 works.
Well, I don't know why it didn't switch in the other ones. It's really weird.
You could. I think you have to highlight them.
No, I didn't highlight that one. Whatever. Okay, so we have a class. And this is going to extend fun.
Well, fun. You're missing a. There you go.
Does it automatically. I knew what I was doing. Okay. So we make a task, a class, right, that extends fun suite. I'm also gonna do this over here and just hold one moment, please.
Some technical difficulties.
No, I just want to make sure I was doing this right because it's been a second. So then we're gonna make a test suite. So this is us gonna be testing our program correctly. So in these parentheses we put a name for our test. So this test is going to be called
Program Worky.
Program Worky. Smile. And inside here, we're gonna make a bunch of stuff. So we're gonna make a couple of variables. So our first value is going to be under 30 pounds. So under 30, which will be into double, right? Which will be like 5.5. And then we'll make a variable called 30. And that's going to be a double. And that's going to equal 30 exactly. I'm going to keep writing these test cases, and Leo's going to explain why we have the ones we have.
Okay. So, under 30 for this test, we're basically going to be checking to see if our program will return 5.5 because, well, we're going to be checking that our program will return 5 because our weight is less than 30. Our variable 30 is going to be checking to see if our program will test our edge case. And our edge case is basically going to be where we get super close to one of the bounds for the assignment or for an assignment or for whatever our program is. And it's going to say, hey, test to see if this will return the right thing, even though it's super, super close to the edge. So we set this value 30.0 and we want it to return 5 still because in our program, we expected anything that is less than or equal to 30 to return 5. Then we're going to go lower than 50, but higher than 30, so we don't get into that if statement for the less than 30. which is 45.4. And we want to see if we obviously get the expected result for that. And then we also want to test another edge case, which is 50, which because we obviously want to check to see if it's less than or equal to 50. And then super high is the highest we can go, which will go into our else statement, which is 100. And just another thing to remember, when we are dealing with doubles in testing, I am going to say it just like Jesse has said it. Please do not use equals equals. Do not use equals equals for doubles. You make an epsilon and you make this compare doubles function. That will
you can
basically
just copy
compare
it
the
every
doubles.
time.
Yeah, you can literally just copy it every single time. Please do not use equals equals because it will pass. It will probably pass in your local machine or your computer or your laptop, whatever you're running from IntelliJ on. You could be running it on a potato for all we care, but it will not pass IntelliJ because some of the values in IntelliJ won't be exactly equal to the value that you're looking for. So please use compare doubles. Do not use equals equals. There's my spiel. There's my little rant about using equals equals.
Good. So as I'm making these, we'll be able to start copy pasting it. And then, so this is the important part that I'd like people to understand about testing. We have some variables that we're going to use that talk about different things, right? So different things that we want to put into the function. Then we should have a correct answer for those things. So what we need to do is we need to go and take a calculator and we need to run our own program correctly. So if we're putting 5.5 in, what will it do? Okay, so 5.5 should say that the weight is less than or equal to 30, which means we should get 5.0. Do not, and I'd like to repeat this about 17 times, do not run your program with print statements, say, oh look, this is what it prints, and then put those in the test cases. Do the work on your own, without the help of your computer, other than like a calculator, and actually find out what the correct values are. So we're now going to copy and paste this 5 times. And we're going to change the variables every time we do it. And I'd like to make it be known that every single thing I've made so far, well, mostly everything I've made, has had a descriptive variable name. So you can actually see by looking at all of these, you can see exactly what thing they're trying to test. Trying to test something under 30, trying to test 30 itself, lower than 50, 50, and super, something that's really high, right? So let's go do the math. So 30, what happens when we put 30 through? So 30 should, because the weight is less than or equal to 30, it should return 5.0. So that's right. So lower than 50. Okay, so if I put 45.4 in, well, that doesn't go into this if statement. That goes into here though. So this is going to be 5 plus 45 minus
45.4.
45.4. So that's 14.
5 plus 15.4 times
30.4 times 0.5 plus 5. So 12.2. 50 should be $15 because it's 50 minus 30 is 20 times 0.5 is 10. 5 plus 10 is 15. Should do there. And then super.
7.
What's up?
Should be 12.7 by the way.
12.7?
Yeah. You did 14.4 or 14.5 instead of 15.5.
Okay. And then we'll have super high, right, which is 100. So putting 100 through means it's going to be else, which is 5.0 plus weight times 0.5. So 100 times 0.5 is 50. So that will be 55.0. So now what we can do is we can run this test suite.
Hopefully everything passes.
And so hopefully everything will pass. Yep. So that's our goal, is that we've done it on our own. We hope that these things go. Oh, it's a VIP from last semester.
Yeah. Oh my gosh.
Instead of doing, can I do that?
So
yes,
you can.
You just have to change your import.
But I have to import it. So I'd have to go here and I have to go import. This is for Matasm01, who asked, instead of doing lecture.packagePricing.pricing, can we just do pricing? And the answer is yes, but you have to import pricing by doing lecture.package. Not that.
Don't do that.
Lecture.packagePricing, and then here.
Underscore.
Yeah, _, which gets all the methods from there. Then this will work. Either way works. Your choice on how you want to do it.
You can also, instead of the underscore, just put dot pricing, and that will
only do
give
pricing.
you just that function. But if you want any other functions from it, it's easier to just do the underscore.
Yeah, I figured I'd show the whole thing here because it makes it a little bit simpler to understand where we're getting things from. So this says test passed, 1 of 1. That's good. What happens if I make this 12.9? What do you think is going to happen here?
What do you think is going to happen as he runs the code? He doesn't even give you guys a chance to answer.
Correct. It's going to say that something failed. Say that this test here, cool test for package pricing.this.compare doubles, lecture pricing, so the lower than 50 at 12.9, it was false. And it was false here. So telling us exactly which test it was that was false and how it didn't work. And that it didn't work. Okay? So each one of... What's up, Joe?
Finish your statement first.
So each one of these things that say test with a test name is individually called a test suite. You might need to have multiple test suites for each thing. For each part of your program, it'll test different things. So this one is specifically testing pricing. But let's say you have 3 functions. You might want 3 different test suites, one for each function. And when you run it, it'll show here test failed 1 of 1. Let's say you had 3. It could say test failed 1 of 3. And it'll show you exactly where it is. That's some of the benefits of testing. Joe.
So the one thing I'll say is, if you pull up that message again real quick.
Got to run it again.
Wait, do you want it to be wrong or right?
Wrong.
Make it wrong. There you go.
So just one convenient thing. You'll notice, because we're using compare doubles, all the assert statement sees is that true or false that evaluates, right? So it doesn't see what the actual expected value was. So this could have returned 5, which it did, or it could have returned 15, it could have returned 100. We'd have no way of knowing right now. So an easy way to actually tell here is if, Logan, if you go ahead and add the clue real quick. So every assert statement can have a second parameter that's going to be a string here. And you can put something here that's going to print out when it fails, right? So if we wanted to see what our actual lecture package.pricing output here, we can put lecture.packagePricing.pricing under 30, convert that to a string, and then we can actually see what we've gotten here. Although we probably don't even actually need to convert it to a string. It'll probably do it implicitly.
It might. We'll find out.
I don't think so.
Yep, it does.
Oh, it did. Never mind.
Yeah. Scala will typically call toString on it if it needs to.
So it says here, this thing was false, and then it says what the actual answer was. If you really wanted to do it here, you could do output and do it like that, and then it might appear a little bit nicer.
It should appear a little bit nicer.
Was false, output was 5.0. So you can actually see exactly what we're testing and what was wrong and how it was wrong. The clue is an optional thing, though. Strong recommendation if it's not working the way you think it should be, to put it, but it's a thing. So I saw that there was a question about unit testing for lists and maps. How do we want to do unit testing for lists and map?
You could do strings like small, medium, large, add them to a list, I guess, for this one. That's what I'm thinking.
Yeah, that would work.
Say that again.
The strings, and if they're a certain size, you add them to the list. Basically, filter out the small, medium, and large ones.
Okay.
While Logan does that, are there any other questions that you guys have? You needed to find what type of list it is.
Yeah, that's what it is.
Give Logan a break. Nobody give Logan.
Please don't give me a break. It's been a minute.
Yeah, it's been a long time for. It's been a while. And a while is like 4 months. So, are there any other questions in regards to unit testing or stack memory or? Yeah, that's it. That's all that little one is.
Yeah.
Or variable scoping. I should mention that too. We are monitoring chat. I feel like the Terminator with like red eyes, or no, the Jesse gif.
The Jesse lasers.
Yes, the Jesse lasers.
Is that still the Discord icon?
It is.
Yes, it is.
Good. That makes me happy.
That's great. I wonder who made that.
I think it was Nick.
Nicholas, I think it was.
That's amazing.
What is it? Plus equals?
Colon plus.
Colon plus equals.
It needs to be immutable or a mutable list for you to do colon plus equals. You just have to reassign.
Okay, so just equals.
Yeah. Equals return list colon plus. Yeah.
Just colon plus. There you go.
I was working on it.
It's okay. We're all learning as we go along. Some of us more than others.
Yep. So, this function that we just wrote here basically says that if we're going to give us a list of strings in, we are going to filter it. So we're going to run through every single string that's in the input list. If the length of the string is greater than 5, we are going to add it to the list. At the end, we're going to return that list. So, let's talk about testing it. So,
we're going to make a new test suite with a test name called string length list, something like that, anything like that. And then we're going to make some variables to test. So I will ask, because I feel like we should ask people's, what do you think we should test?
Give us sample input output.
What is something that you think we should test?
I'm going to pull this back up so you can see the actual code.
If we still have people here, what should we test? This is where we, like, the moment where we go silent, and we're kind of hoping that you guys are, like, typing, but we don't really know if you guys are typing, so this is like that awkward portion of the stream.
Here's where we need the Jeopardy music.
Yes.
Here's where we need any music at this point. Okay.
Dog, can you give us? So I want it to look like this, right? I want it to look like input, and
give us a list.
Give us our input, which should be a list of strings, and then I want output, which should also be a list of strings. And then I want a separate message that says what you think it's testing.
Making the list might take a while. I'm
learning that on the guitar so I can play it next time.
I mean, you can play a bunch of different things on the guitar for music as of right now.
Oh, yeah.
I wish I had a talent. My talent is saying random things at awful times, and
that's not a bad
that's my
talent.
talent.
It's a bad talent at all.
That's
So
comedy,
just so everyone knows, we're not just sitting here for no reason. The reason we do these review sessions is to help you all out, so that way you all understand the material. So we're asking for you guys to do for you guys to give us input output, because it helps you learn it. We're not just sitting here doing nothing for no reason. So please do give us input output. Also, Leo, I think I yet again have a different background than you. There's input and output. Okay, so
That's what we like to see.
this is what we need. Bar, Tasm input. That way, if it screws up, we know who to blame.
We're putting you on the spot.
Yep.
This is your input. That's what I was worried about. No, don't. No, I really don't. If that was what you were worried about, don't be worried about putting you on the spot and your input fails. Okay, it's not that big of a deal. We fix it. We will fix the input.
I mean, did you see how much I had to flounder around with getting stuff to work correctly before already? So
yeah, I mean, come on, Logan didn't even know how to make his Scala work. Let's be honest here. Logan's in his fourth year computer science, and he couldn't make Scala work.
Damn straight.
The same IntelliJ issues that you guys had, Logan just had. So don't
enjoy the Japanese music. I'm good. That's important.
Yeah. So that's great. Yep. I mean, did you play it?
No,
I thought I just.
You and I sung it.
Yeah,
you and I both sang it.
A second, I was like, did we play it? I just realized I sung it. Oh man, that's short-term memory loss. I didn't enjoy it. Too much pressure. There's
all right.
Pressure
So
Jeopardy?
I have one test. I'm going to run it. Let's see if it works.
It won't.
Why won't it work?
Because you spelled things wrong.
Did I really? That's a good answer. This is the expected output.
Yeah.
Let me label it better.
Yeah.
That works. That proves our code worked, right? So what did this test? This was just a regular standard test, to be completely honest, right? One of the edge cases, we're always looking for edge cases, right? One of those edge cases that we're looking at should be what happens when it's 5. Now it shouldn't go in. So let's say we were to copy this list again, right? So we were to copy these and make this make them called like edge case 5 or something like that. Edge 5 input, and this one will be called
Edge 5 output.
Right, and so let's say this one just says doggo with 1 O. We did the exact same assert statement here. We actually don't want it to be what edge 5 output is right now, because our program shouldn't take any of these. None of them are greater than 5, so this should actually just be an empty list. So we want to make sure that, well, it's an empty list. Which it is. Everything passed in here. So because this is an empty list now, that's one of the edge cases we want to test. Another one that we'd like to test is the empty one. Empty is always a really good and easy thing to test.
Edge empty.
Yep.
Edge empty. Nice.
Nope. Testing what happens when you don't actually give it anything. The answer is, it won't do anything. There's nothing in, when we go here, there's nothing in string list, so it just goes past the loop. Doesn't matter if you use brackets or parentheses for lists. Yes. You have to use parentheses.
You have to use parentheses in Scala.
You use brackets when you're declaring what type of list it is, when you're putting like a data type in there, and you use parentheses for lists.
Nope. Map is also parentheses.
Yep, you just put the word map in front instead of list.
There's also one other test case we can do.
What's the other test case, Leo?
The same. So don't copy and paste the empty one. Let's just copy and paste the one that you had before. Sure. Add Leo with another, I think 4 O's.
Make it Leo Trim.
Oh, that. Or Leo Trim. You know, my full first name. By the way, that is my full first name. That is, Trim is not my last name. Just want to say that. And put Doggo with the second O again. Okay. And list should be Doggo and Leo Trim. Yes, Trino is actually a nickname. I have a funny story about how Trino came out, but that doesn't matter. Okay.
It's Trino.
I don't know what to name it, man.
Hold on. I just need to take a picture of this. This is funny. If my phone would like to work.
Okay. So the whole point is this should test that this works with more than one string.
Yes, but there is a specific thing that Autolab will look for when you are testing with multiple elements inside the string. Or inside your list. I'm sorry.
I see.
And I want to bring this up before you guys scream at us saying, "Oh, but you didn't do this in the review session." We are going to do it. So
let me hold up. Let me fix this.
Yes, you could fix this.
I know what I know what I'm doing. Okay. Let's try it again.
Yes. So let's see if this will pass.
Oh no, it won't pass.
So our test fails, but we have the same elements in the list as they expected. So, to overcome this issue, before we test it on our assert, we need to sort our list.
Well, you can test it in your assert.
I mean, yeah, in the assert, I'm sorry. So we can call .sorted on our method call, and we can call .sorted on the output.
And basically what that's going to do is whatever your output is, this output, your expected output, right, and what your actual function output is, it's going to sort them the exact same way. Because order doesn't matter as long as the stuff's in the list the same way. So when we rerun it again, everything passes because it's all in the list the same way. So just know when you're doing lists and the order of the list doesn't matter, make sure to use .sorted.
You need to use .sorted, or Autolab will say, no, your code no worky.
Basically, yeah. Okay. Maps are going to work the same way, except maps you never have to use .sorted for. They're literally the exact same way you test it as a list. You just use equals equals, make another map, and do it the same way.
Yep.
It's not rocket science, I swear. Okay. What else?
Anything else that you have questions about, or confused about, or need a clarification about?
Or just have a question for us in general.
Or any question in general now. It doesn't matter. It doesn't even have to be specific to this anymore. Another example for stack memory.
Let's go into these test cases.
Let's just do a test case. Sure.
We'll not do the string length one because it's got lists.
Do this one. Let's do it for calling this assert case because it's gonna be. No, let's do it for this one.
We'll do it for super high.
Yeah, we'll do it for super high, and I'm not gonna actually run it as a test case because you don't ever need to do stack and heap for a test case.
Yeah.
So. Okay.
Before we get into this, there's a question that says, when are we going to learn pseudocode?
It's not like a thing you learn.
You don't learn pseudocode. Pseudocode is you just going in plain old English and saying in plain old English what you are going to do for your program or what you are going to do for your code.
But it's not in like sentences. It's kind of just
yeah. It's more like saying like, hey, if this is true,
code
then we're
without
gonna
worrying
do
about syntax is really what
Yeah.
pseudocode is.
Yeah.
yeah. So you don't care about the syntax as long as you can get your point across. It doesn't really matter.
The important thing is just understanding the structure that you're going to be writing out, and then you can actually implement that in code.
That. All right, so let's go through.
Let's move into this stack example.
So we're going to start here in the main, right? So begin main stack frame. The first thing we're going to put on is the args. You don't know what they are, but they're.
I can tell you've been using PHP.
Hey, I haven't started to put semicolons at the end of lines yet. We haven't gotten that far.
You're putting question marks at the end, though.
Sue me for liking
it's
PHP.
Okay.
So our next line says, actually, you know what? I'm gonna just edit this a little bit.
Please do just x equals or var something equals,
and then I'm gonna print x. So we have a variable named x, and we want it to be the answer to whatever pricing of 100 is. So here we are going to go down here now, and we're going to make new stack frame. Begin pricing stack frame. We have a weight, so name is weight, and the value is 100.0. Then we have an if statement, so we will traverse the if statement. Do we execute this line?
We're asking you, by the way.
Yeah, this is a question to people.
Through the chat. Through the chat. Let's get poggers in the chat.
Alright, so /ban Trino saying poggers. Alright, so I'm gonna assume no one's gonna answer me. I'm just gonna keep going as if I'm talking to an empty room.
Yep.
So we don't actually do anything on this line. This line doesn't execute. We say is 100 less than 30? No? Okay, next. Else. Okay, so is 100 less than 50? No? Else. Okay, so we do go in here. Now this is just an else. Now we're going to execute this line. So we're going to return 5 plus the weight times 0.5. So the answer here is 55.0. And then we're going to just end pricing stack frame. Now we have x, and its value is 55.0. Also, anytime I say end stack frame, that means it has been destroyed, to make that clear. And then we're going to print it, and then we end the main stack frame. What was the question? The question was, do we go in there? You wouldn't do else block.
You would want to, actually.
Yeah. Well, yes. So you do say begin else code block, and then you go into it.
Since it's only one line, it's not really significant, especially since it's not assigning anything. So there's nothing actually in that else block. But
that's what it would officially looks like.
Yeah.
But the second we end this, it gets destroyed. So it's like.
Are there any questions about that?
And this works the same way no matter what number we put in, right? I could say that this is 25, and we just replace this value here with 25, and then replace the return value. And that's how this stack would look every single time for the pricing function, if we just call it like we do in main.
Are there any other questions about that? Or comments? Or questions about other things. Or anything of that nature or sort.
Or question comments.
Or questions. Questions and comments combined. Questions. You think you get it somewhat. If you are still confused,
watch the VOD of this.
We are here.
If you have time, more examples. On it, I'm not sure how many more examples we could reasonably do without just like getting the same thing over and over again.
Yeah, it's starting to become repetitive.
Because I can't
if we were
do
going over heap as well.
Yeah, I was gonna say if we were doing heap,
very limited in the actual variables we can use. Just going over stack.
So I'm gonna say don't worry about more examples. Take the 2 or 3 examples that we did here, plus the examples that Jesse has in his lectures, and just rewatch those, or do them on your own, or just find a random piece of code, right, and see if you can get what it's doing, and if you can write the stack for it. Once you understand how to write stacks, you'll like understand how to do it.
I'd say one thing you could do if you want to study is go through all of the lecture question ones, ignore everything that's not a primitive, and just write out the stack for it. So don't write out your lists, don't write out your maps, but like all your integers, all your booleans, all that kind of stuff, and like your actual code blocks. You can write those out.
And TAs are more than capable of you just coming into office hours and just asking, hey, can I recite this stack example for you? We are more than capable of listening to that. I highly encourage that.
If you make a private post on Piazza, just like, hey, I tried writing this stack frame out. Can you just check my answer?
Yeah, we can definitely do that for you.
We're more than happy to do that.
You show how to use the debugger. Yeah. Sorry, I got some
debugger.
I'm going to. I got some new masks, and they require you to put filters in. So I was like, while we're answering questions, we were doing that.
Did he say that today?
Wow,
we're already on the debugger. Wow.
I mean, debugger should be like day 1. Okay, so why did that go over there? What the hell? Okay, so we can click here to make this nice red thing. Basically, what that means is we are going to stop on this line, and then we will have manual control of the program from this point on. So if I run this main, we'll have a nice screen pop up. Oh, sure does.
You have to specifically run it in the debugger.
Yeah, so it's this like little bug thing up there.
Looking thing, yeah.
So right now we can see what this is and what the args are. So what I'm going to do is I'm going to step in. So there's 3 things you need to know: step out, step in, and step over. Step over means we're not going to go further into this line. We're just going to go to the next line. Step in means I want to go into whatever is in this line. And step out means I want to get out. Most of the time, you will step in. I'm going to step into this line. That's going to take us into the function. Okay, so we have the current value here. So wait, I'm going to step in. It says that doesn't matter. We go to the next one. We go to the next one. This one stepped in because it's an else. Going to have this value here. And we can see down here in variables that wait is that, right? I'm going to step in. It returns. Stepping in again means we go here. We now have the value of x. And then step into print and it will be done. It's a really terrible example to use the debugger. Yeah, so step in may go into other files, into how the program, the programming language actually like works under the hood. That's totally possible.
Especially if you put any like breakpoints in your tests, it's going to typically go into the libraries that are calling assert.
Yep. If you are debugging your code, my recommendation, and this is the only time I'll actually make this recommendation, is to actually just test through a main. Is to put your debug on something in a main and just go that way. That way you have less of a chance that you'll actually hit external files.
Typically, especially my personal suggestion, you can do through the main. But also, if you put a breakpoint on your actual code and then you run your tests in the debugger, it will still stop on that point in your code.
Yeah, but it's like after through the code, it'll then bring you into tests and stuff.
Yeah.
which is scary.
Okay. If you end up in a file that you shouldn't be in, just press step out.
That's the whole point of step out. Step out is just like the.
And if step out doesn't work, just
quit.
Close the debugger and
close the debugger
try it
and
again.
go again.
Yeah. Actually, do you want to run through that debugger one more time though? Because Sam was talking about going through stack memory. You can actually look through the frames there while you're going through.
Yeah, it's just I'm gonna add some just like random variables.
Yeah.
Instead of just random numbers.
Yeah. It doesn't really matter, it's just so you can see at different points.
Yeah.
So you put something inside of the else.
I'm going to.
And then put something after that so that we can stop on.
This looks good to you, Joe?
Yeah, that looks
fine. Assign one variable in the else because that's going to execute, so we can demonstrate code
Well,
blocks.
it's assigning the Z.
It's assigning
no, like assign a variable, or sorry, define a variable. I'm using the wrong words.
That'll work.
Perfect.
Okay, let's try this again.
The debugger there.
Okay, so nothing in here. Joe, I will step. You speak.
Yep. So before you actually step, so you'll see on the left, there's the actual frames here. So this shows you all of the stack frames that are going on, right? So right now we've just got our main stack frame. So it just contains our arguments that we pass in, which is that array, which there's no arguments right now, so nothing. And nothing else has been defined at the moment. So then you can go ahead and step in. So now we'll see that we've opened up a third stack frame, right? So that's pricing. And you'll see that our weight is actually assigned. So that's where we kind of passed in that name weight value equals 100, right? So then we can just keep going into the else here. And we'll see various things just get assigned, added to the stack. All right. So now you'll notice we don't get another stack frame, but actually step in one more time. You'll see that K is assigned here, right? So this is because we're in the code block, we're still in the same stack frame. K is visible here. But then if we continue to that next line, right? And once we get out of this else statement, you'll suddenly see K just disappears, right? So that's just demonstrating the actual code block visually for you guys, if that helps. And then after this goes, we'll just see Z here, which is our return value, evaluate and return. And after this line is finished executing, we now see just X is equal to 55, right? And you'll notice that our pricing stack frame on the left no longer exists. So. Does anybody have questions about that? Does that help to visualize it a little bit?
Hopefully that clears up a lot of stack frame questions as well. Because seeing it happen in the debugger is usually it's easier to see what's happening within the stack. And then one of the questions is, how do you set a breakpoint? So in between the number, the line number and like the little lines where like they start, you can just press on the side and it'll place a breakpoint there. Like if you just go right next to the number and just click on it, it should set a breakpoint. Or if you right click, I'm pretty sure you can also set a breakpoint.
Then one other thing to note with the debugger is you can place multiple breakpoints and it will always stop when it hits a breakpoint. So if you put one at var x here and then put one into the actual function that we're calling, so right there, yeah. If we rerun the debugger, then there's this little like resume button on the left. It looks like a play button merged with a pause button. Yeah. So that will just basically start your program running again, and it'll keep going until it either finishes the program or it hits another breakpoint. So if you're getting a little tired of just constantly pressing step into, you can just set where you want it to stop and run it to there again.
I'm very happy you talked about the debugger today. That helps a lot.
Friday, not today. Friday.
Friday?
He said Friday, man.
Wow. I'm surprised.
Be less surprised or be more surprised. I don't know which to be surprised about.
What week are we in? I just want to check. Oh yeah. Okay. So yeah, I highly recommend the debugger for your LO1 lecture tasks or application objectives. The debugger is going to be your best friend because you can see exactly what's going on.
It's going to get more and more useful as you go on too.
Yeah, and later on it will get much more useful.
And enjoy it, because in 220 the debugger gets so much harder to use.
It's terrible.
I wouldn't say it gets harder.
No,
but there's more to it.
It
but
does.
There's more to it, and it's different. It's a different debugger than what IntelliJ will give you. It's not that it's harder necessarily.
It's definitely harder. In IntelliJ, you press a button.
Okay, for the record, I'm biased only because I love 220 and I love the debugger from it.
It's harder.
Yeah, but no, it's really not that much harder. I don't know what you're talking about, man.
All right.
It's just this is all personal preference, by the way. To me, it really wasn't that much harder. It's essentially the same idea. So
we stay on Scala in other classes. In 250, you'll still be on Scala.
I hope
220 is going to be in C, and then once you're past that, 341's in assembly. 331, typically they let you choose between Java, Python, and C++.
And they still do that. So
yeah, and then after that, it's class by class basis. But typically it's whatever you want to use. So there's that. I think the only constraint in the upper level classes was Logan and I took 442, and we had to use PHP for the web server, as opposed to Python or anything else.
Which is terrible.
You say it's terrible, but you were writing PHP like it was nothing.
Oh no, I really enjoy PHP now. Don't worry about it.
I would hope that Scala stays as the 250 language.
I think it probably will.
I don't see any reason for it to change.
Well, I mean, there's been a couple differences, so it might change.
If it does change, it would change to Java, and if you know Scala, you basically know Java in a weekend. So,
well, wasn't it taught in like C++ before as well?
No, this is not Java.
It was in Java.
Okay.
Also, C++ isn't that difficult to learn either from Scala.
No.
It's also object-oriented.
I guess, yeah. I guess that makes sense.
Yeah. Honestly, like, after 116, learning languages shouldn't be a difficult task.
Yeah.
You'll have your, like, week or so where it's kind of painful because you don't know the syntax. But then, like, you just actually start doing it and you're good.
Yes. So just for reference, that first week that you will be learning a language, you're going to hate it. Please don't give up that first week. It's going to suck. Everybody goes through it. It's like, please just don't give up during that first week. We have a question. What is Scala used by? Any major companies? I've never heard of Scala before. Logan, you know this because I remember you answered a student before.
So Scala is used a lot in data pipelines. So in getting data from one place to the next, Scala is used a lot. It's used
real big with Spark.
It's big with Spark as well. It's used. It's not like the most popular language known to humankind, but the benefits of Scala, at least for us, are a learning thing, right? We use it so that way we can have so we can use functional programming at the same time as object-oriented programming and concurrency, though other languages have gotten that a little bit better now. But we use Scala because of those features and because it is a well done language, even if it's not constantly used everywhere. And as we said, once you know the concepts of a type of language, it takes 5 seconds to pick it up. to pick up another language that's similar. So learning Scala will be similar to every single other like object-oriented language.
I've also been seeing it more in companies now, so
yeah,
I actually have been.
Scala was getting on the rise.
And then Kotlin happened.
Scala 3 coming out may have put a wrench into their growth, but
it's going to be the same way Python 3 was.
We'll see.
I don't remember what happened between Python 2 and Python 3, so.
A lot. Yeah. Python too bad.
I will say, though, the big thing is once you're getting the hang of, like, just basic, like, understanding object orientation, understanding functional programming, all those concepts, you're probably going to have, like, no issue actually reading languages. It's just going to be learning how to write them. That is your main thing. So it's going to take a lot less time.
Yeah, like knowing Python and JavaScript severely helped me last year when Jonah had to write PHP. And like we were told, like, hey, everything needs to be PHP about 10 minutes before. So it was considerably easier for me to learn how to write PHP at that point. Have we learned Ruby in any of our classes? I don't think any of us have, but there's definitely classes you can take that have Ruby in them.
I think a lot of like the data classes do.
Yeah.
Some Ruby stuff.
Or R.
I think R is the more popular language, at least at UB.
It's the more popular language, full stop.
I mean, yeah, that's true.
Ruby's also with web dev.
They also they'll use Rust a little bit, I feel like.
Do they use Rust a little bit?
There's at least a small push for Rust.
I don't know about Rust. I know R and Ruby for sure.
Pretty sure Carl was using Rust in one of his classes.
That sounds about right. Sounds like Compilation or something like that.
Yeah. Okay. That makes sense.
And Go, I think, is starting to inch its way in.
But you don't need classes to learn a language, by the way, guys. You can honestly just pick up a project and say, hey, I want to do this project in this language, and just use that language.
Project, watch some YouTube videos, start cranking it out. It'll just come with practice.
Obviously, if you're learning basics of a language and you put it down like you know the language completely on your resume, they're going to be like, hey, do you know this language? Because we're going to test you on this. And then you're gonna get caught, and then you're gonna look like a dum-dum who doesn't know the language because they watched like 2 YouTube videos on the basics of it. So, don't do that. Actually, do a project in that language, and then you can put it on your resume.
Yeah. So, well, how everyone feeling pretty good?
Yes, does everyone feel good about their LO1 content? Their LO1 understanding, their LO1 conceptuality. I don't know if that's a word. I'm going to make it a word now. Conceptuality. This is like me and questions. Like questions and comments. Questions.
Feel more confident after the review session. Thank you guys. That's the goal. The goal is that you guys all feel more confident after going through this, and if you don't, you can rewatch it like 4 times and then feel even more confident.
I hate you.
Joe just, what did he do?
Don't worry about it.
He's being useless.
Okay, that sounds about right. All right. Well, with that, we're gonna get going for the day. Everyone have a nice day and good luck on interviews for the rest of this week. And make sure you're working on Pale Blue Dot.